Okay, so in this lesson, we're going to integrate with respect to time. Okay, now most of the integration we've done so far, although it's not been non-exclusive, it's been with respect to x. So, for example, we've got y equals 3x. Let's integrate that. Okay, let's integrate that with respect to x. Okay, so in this case, it's with respect to time or dt. Okay. And it's pretty simple. Integrate motion, questions, remembering to always plus c. Now, it is here where you're going to get into massive trouble if you don't plus c. And hopefully you'll see why. Let's get straight into the video. Okay, so given, what's another symbol for this? Hopefully you're shouting out is acceleration. It goes, it's the same thing. Initially, so what does initially mean? T equals 0. So remember, initially means t equals 0. The velocity is 6 meters per second and the displacement is 4 meters. Find the velocity and acceleration functions. So I'm just going to start with acceleration equals minus 2 sine half t. So if I integrate that, I'm going to get velocity equals, now I don't know if you remember this, but it's exactly the same thing. Not exactly the same thing. The derivative of sine is positive cos. The integration of sine is negative cos. So we're going to get cos. Now this is what stays exactly the same. So half t. We're going to divide by the derivative of inside the brackets. So it's a half. And remember it's negative, and we've got negative 2 times there. So that negative and negative will cancel out. So let's do that. And then this 2 is going to multiply up the top. So we're going to get V equals 4 cos half t plus c. Now to find out what V actually is, we need to substitute this initial at t equals 0. Initially the velocity is 6. So let's write that down. At t equals 0, v equals 6. Now, cos of 0 is at 1. So we're going to get 6 equals 4 cos of 0 because we're substituting in t equals 0 into here. And we've still got the plus c. So therefore, 6 equals 4 plus c. Therefore, c equals 2. Therefore, our velocity formula will be this whole thing, but we know what c is now. So it's going to be 4 cos half t plus 2. All right. Now what I'm going to do is I'm going to rub off the things on this left-hand side so I can keep working away. Now let's do what acceleration is. So I'm going to use a different color. Let's use green. Acceleration will be the integration of cos. Now the integration of cos is positive sine, so we don't have to worry about anything. So we're going to go 4 sine. Remember, this stays exactly the same, the half t. But we're going to divide by that, by the derivative inside of that, so that's a half. And then we go plus 2t, because we integrate the 2. It's like when we get a constant, we go 2x, but we're doing with respect to t. And then we've got a plus c. I'm going to put plus c1, all right, to just differentiate it to c. And I actually don't like that green, I'm going to go darker. So we go, but we have these conditions. At t equals 0, the displacement, oh yeah, I'm doing displacement here. And we already have find velocity and displacement, functions. Because if we're integrating velocity, we will get displacement because we're going up the chain. So at t equals 0, x equals 4. Now x equals, if I just fix this up, it's going to be 8. sine half t minus 2t plus c1 at t equals 0, which is what I have up here. Everything, sine starts at the origin, so it'll make this 0, make that 0. So therefore 4 equals c1. So therefore x equals 8 sine half t minus 2t plus, what's our c1? It's 4, so it's going to be plus 4. All right, so just so you're aware, initially means t equals 0. Just remember that with motion functions we can use trigonometry. Actually, we use that quite a bit, so just be aware of that. And yeah, let's go on to the next example. All right, example 2. Given the acceleration of an object is 12 meters per second squared, initially the velocity is 4 meters per second, and the object is at the origin. So initially, t equals 0, the velocity is 4 meters per second, and the object is at the origin. Find the displacement and velocity functions. So essentially the same thing as we've done now. So let's go. A equals 12, because that's what it says, acceleration equals 12 meters per second squared. Velocity, we'll go v equals the integration of that. That's pretty simple, 12t. Remember to go plus c. At t equals 0, v equals 4 meters, so v equals 4. So we get 4 equals 12t plus c, therefore c equals, that's 0 by the way. So c equals 4, therefore our velocity formula will be 12t plus 4. All right, for acceleration, for displacement, we're going to integrate this again. So we're going to get 12t squared on 2 plus 4t plus c1. So we get x equals 6t squared plus 4t plus c1. And this one's interesting. Initially, so at t equals 0, the object is at the origin. So that means that x equals 0. Okay? So 0 equals c1. So essentially, this is our displacement formula without the c1. So therefore, x equals 6t squared plus 4t. Right? The last question is like, find when the object is stationary, and what is the displacement then? So the object is stationary when it has no speed. So that means it has no velocity, because remember that speed and velocity are essentially the same thing, except speed is the absolute value. So object stationary when v equals 0. So we've got to get our velocity formula, which is there. So I'm going to change colours. So we're going to go 0 equals 12t plus 4. So we've got to solve for that. So we get 12t equals minus 4. Oh, we can't have this. All right. You can't. T equals 0 is the beginning of time. You can't have negative time. So there is no place that this is stationary in this case. We can't have negative time. We can have negative displacement, we can have negative acceleration, we can have negative velocity, but we cannot have negative time. Nothing exists before the world began. So nothing exists before t equals 0. But the point remains, when v equals 0, we'll find when an object is stationary. And then when we find that time, we substitute that into our displacement formula. So unless I've done something wrong, I think that's it. Yeah, I should have done the question with -12. I think that may have made a difference. Maybe it hasn't. Haven't sorted it out. But that's it there. All right. Hopefully that makes sense. If you've got any questions, please ask. Peace out.